At that time when you're writing it, there's already a sense that exoplanets are out there, and we might be able to be looking for biosignatures for on those exoplanets.
Pretty much. So I finished my PhD in 2015. Mm-hmm. We found the first exoplanets in the kind of mid to late 90s. So exoplanets were known. It was known that some had atmospheres. And from there, it's not a big jump to think, well, if some have atmospheres, some of those might be habitable, and some of those may be inhabited.
So how do you detect, you started to talk about it, but can we linger on it? How do you detect phosphine on a faraway thing, rocky planet? What is spectroscopy? What is this molecular fingerprint? What does it look like? You've kind of mentioned a wave, but what are we supposed to think about? What are the tools? What are the uncertainties? All those kinds of things.
So the path can go this way. You've got light, kind of pure light. You can crack that light open with a prism or a spectroscope or water and make a rainbow. That rainbow is all the colors and all the invisible colors, the ultraviolet, the infrared. And if that light was truly pure, you could consider that rainbow to just cover continuously all of these colors. But if that light goes through a gas, we may not see that gas. We certainly cannot see the molecules within that gas. But those molecules will absorb some of that light. Some, but not all. Each molecule absorbs only very specific colors of that rainbow. And so if you know, for example, that shade of green can only be absorbed by methane, then you can watch. As a planet passes in front of a star, the planet's too far away, you can't see it. And it has an atmosphere. That atmosphere is far too small, you definitely can't see it. But the sunlight will go through that atmosphere. And if that atmosphere is methane, then on the other side, that shade of blue, I can't remember if I said blue or green, but that color will be missing because methane took it. And so with phosphine, it's the same thing. It has specific colors, 16.8 billion colors, that it absorbs it and nothing else does. And so if you can find them and notice them missing from the light of a star that went through a planet's atmosphere, then you'll know that atmosphere contains that molecule. How cool is that?
That's incredible. So you can have this